Hi there, and welcome back. This is a multi-part video series on how to defeat the Ender Dragon in hardcore mode with Minecraft Math. This is episode 6. We've accomplished a lot in hardcore mode so far, but have not really begun searching for diamonds, and now it's time. We're going to need diamonds in order to have the armor and weapons needed to defeat the Ender Dragon. I have a controversial take on mining diamonds. I do a little mining when I first set up my base, to get enough iron for armor and a pickaxe and an anvil and such. If I discover diamonds, I only mine 3 of them, and I leave the rest of them there. Make a diamond pickaxe, and then wait to mine the rest of your diamonds until you have Fortune 3. You'll thank me later. Fortune 3 increases the diamond drops from diamond ore, so each block drops 1 to 4 diamonds instead of just 1. You'll need to search for a much shorter period of time for those remaining diamonds. Now, I have a way of mining diamonds that I've used for years, but my students wanted me to make a video on the best way to mine for diamonds. Thank you, Isla, for the suggestion. And it occurred to me that the way I've been doing this for years might not be the best way. So, what is the best way to mine for diamonds? Well, we're going to learn by doing what all civilized humans do. We're going to do a science. Yes, we will do the scientific method in this video. So buckle up. If you have to do anything from a science fair project to your organic chemistry lab report, you'll be glad to have the tips. The scientific method consists of these steps. And I use the Science Buddies page all the time as a teacher and a mom. It's a trusted resource. First, you need a question, and you phrase it in the form of an open-ended question, such as, what's the best way to mine for diamonds in hardcore mode in Minecraft? We don't know the answer, so science will help us learn. Then, you do background research. This is a really important step. Number 1, it helps you learn what other people have done in the past. Number 2, it helps you decide how to run your own science experiment, create the best possible procedure, and avoid the same mistakes others have made. Number 3, you learn who are the people in the world that know the most about this topic, and you can get clued into their knowledge and also give them credit for what they've done before. In my background research, I learned some key facts about mining diamonds. Diamonds are found at level Y equals 15 and below in the overworld. They may spawn once per chunk in veins of 1 to 8. Chunks are volumes over a 16 by 16 area in the XZ plane. Recently, some Minecrafters have discovered a technique where you find patches of clay in a river or a swamp and dig straight down. A YouTuber named Farzi posted a detailed video on how to find diamonds using clay patches in a swamp. And after doing a little of my own experimenting in a creative world, I decided his method was worth checking out. Based on my research, I needed to do an experiment to see whether my old technique, which I call branch mining, is more efficient or less efficient than Farzi's clay patch mining in hardcore mode. One more thing about background research. It is really important to cite the sources you used. You have to give credit to the people who have done the work before you. Some teachers or readers will be okay with web links like what I used. Others will want you to write a formal bibliography with your sources in MLA or APA format. Make sure you use the format your teachers or professors expect. The next step is to create a hypothesis. A hypothesis is a prediction for how you think your research will turn out. It should be an educated prediction, not a wild guess. I predict branch mining will be about the same efficiency as clay patch mining, in which I need to dig all the way down to the deepest levels over and over again. I think the uncertainty of finding diamonds in branch mining will roughly cancel out my digging down over and over again in clay patch mining. But we'll see. Next, you have to decide how you're doing your experiment. This is detailed in your materials and methods section. My pro tips for this section: provide just enough detail that someone else could do the experiment just by reading your report. After you write down your procedure, follow it. Do not deviate from the plan. If you run into problems and have to change your procedure, write the new procedure down, then start all over again. Don't do an experiment half with one procedure and half with another, or worse, fail to write down what you changed. Your results won't be any good. And number 3, be sure to plan for how you'll collect your data, and make sure your data collection plan matches your hypothesis. This should be clear in your materials and methods section. If your hypothesis says something like, I think sugary foods will taste better, you need to be collecting data on how sugary the food is and also how good it tastes. Make sense? I'm going to use these materials, and here's my procedure. I'll compare branch mining to clay patch mining and collect data on how efficient it is. For this data, I'll count the number of blocks that I mine out that are diamonds and non-diamonds for each technique. I'll keep mining with each technique until I gather 29 diamonds. This is how many diamonds you need for your full suit of armor, pickaxe, and sword. I'll explain the techniques as I mine. Here we go. I'm making a peaceful world and equipping myself with a netherite pickaxe and a shovel. Branch mining is my usual technique. For this technique, I first dig a staircase down to level y equals 11. I chose y equals 11 because the lowest lava pools start here. Once I get there, I mine straight forward for about 64 blocks or so. Then I start mining side tunnels. Each side tunnel goes out about another 64 blocks, and the side tunnels are 4 blocks apart. I can use F3G to see chunk boundaries. If I find diamonds, I'll start the next branch one chunk over. Let's watch the branch mining real fast. Okay, in the end, I collected 31 diamonds and 3,042 non-diamonds. On to clay patch mining. For clay patch mining, I'll use a swamp biome only. In my creative world experiments, I sometimes found diamonds 2 blocks south of the center of the patch and sometimes 8 blocks north. In my research, I learned it's important that the center of the clay patch and the potential diamond location are both in the same chunk. So I'll turn on chunk borders with F3G. When I find a circular clay patch, I'll look 2 blocks south of the center. If that's in the same chunk, I'll dig a spiral staircase down. Spiral, because in hardcore, I would never dig straight down. If I find diamonds, I'll dig them out. If I don't, I'll return to the surface. Now, if I find lava or a cave, I'll give up on that clay patch. But if not, I'll look 8 blocks north. If that's still in the same chunk, I'll spiral down again. If there are no diamonds in either location, I'll call that one a dud and move on to the next clay patch. Here's the clay patch experiment playing out. In total, with the clay patch experiment, I found 33 diamonds and 1,832 other types of blocks. And my experiment is done. I followed my procedure just as I said I would. On to the next step of the scientific method. The next step is when you display your results. Take your data and put it into a table and a good visual display. Since I collected different numbers of diamonds with each method, the best way to compare my methods is to divide non-diamond blocks by diamond blocks, giving me a non-diamond to diamond ratio. A lower ratio would tell me that's a more efficient method. For clay patch mining, my ratio was 55.5 non-diamonds for every diamond I found. For branch mining, it was 98.1 non-diamonds for every diamond I found. I also kept track of the failed clay patches in the clay patch method. In this experiment, I hit 3 of them. I have some pro tips when it comes to displaying your data in a graph. Number 1, are you comparing 2 or more different categories of things? If so, a tried and true bar graph is your best bet. Number 2, did you collect data that changed continuously or changed over time? If so, consider a line graph. Number 3, did you collect data that represents parts of the same whole? If so, a pie chart might be the graph you want. And number 4, the most important step, the type of graph may not be very cut and dry. Experiment with different types of graphs and then look at them critically. If you saw that graph for the first time, what would you learn from it? Show your graph to a critical friend or a teacher. Do they understand what it means? If not, go back to the drawing board and make a different graph. My data compares 2 different categories, the branch mining and the clay patch mining, so a bar graph it is. The next step is the analysis and discussion. You can't forget this part. You should write a few paragraphs about your experiment and the results you got. A good analysis and discussion section has these elements. First of all, you discuss what your data means and whether your hypothesis was supported or not. Avoid words like proven. You gathered evidence, and the evidence points you in a certain direction, but when you're truly doing science, you're letting yourself and others gather mountains of evidence, so you're not just relying on one experiment to shake out the truth. You're part of the big brain trust involved in doing science. We're all in this together. You talk about your procedure, and if, looking back, you would have made any changes to it. Did the experiment go as expected? If you knew then what you know now, what would you have done differently? And you make recommendations or a call to action. Does your experiment suggest that people should do something? In my discussion, I point out that the clay patch mining method is more efficient based on what I measured, non-diamond blocks per diamond discovered. But there were some things I didn't measure that might have given useful information. One was the time it would take overall. If I could do the experiment again, I would factor in the time needed to seek out a swamp with lots of clay patches, measuring the time needed to find the diamonds from beginning to end. It might change my recommendations. I also noticed that the clay patch mining was more stressful and frankly less fun than branch mining. Maybe it's because branch mining is more familiar to me, but if I did the experiment on other people and surveyed them on which method they enjoyed more, I might get useful information. After all, we play video games to have fun. Finally, if I were doing a more robust experiment, I would run the same test many times on different world maps and average the results. I bet I would find a lot of variety based on the seeds of other worlds. You should write up all of these sections in a lab report and use a grammar and spelling checker to make sure you've done a professional job. And if you're entering it in a science fair, get a trifold board and clearly label each section of the scientific method. One last thing is to never, ever plagiarize a science project. But I should point out that it is valid science to do an experiment that someone else has done before and add your own twist to it. Scientists and professors and professional researchers do this all the time, and it adds to the overall body of knowledge of science. So if you find an experiment online that someone else has done and you want to do it, give them credit in your background research, modify their experiment, and try it yourself. I can tell you that if you have a swamp available in a survival world in Java 1.17, digging down 2 blocks south of the center of a clay patch seems to be a pretty reliable way to find diamonds. If you don't have a swamp easily available, you can do branch mining and feel pretty good that you will discover diamonds too. If you'd like to see my lab report, it's linked below. If you adapt my experiment and do your own science, please give me credit. Now that I have all my diamonds, I'm ready to enchant my armor and weapons on my anvil, and it's time for monster hunting. Tune in next time to learn about the engineering design cycle and hunting for ender pearls. Until then, take care, and thanks for watching.